In problem number 2, we've got a probability that x is less than or equal to 5, and we want to find the probability that x is greater than 5, given that it's a normal distribution with a mean of 3 and a standard deviation of standard deviation of 7. So basically what's going on here is we've got this normal curve, and I want to find this area over here and then the other area on the other side. And what we're going to do is we're going to convert this to a z-score, and we're going to use our z-score formula of x minus mu over standard deviation, and we plug in 5 minus 3 divided by 7, get 2 over 7, or 0.286. We always want to round our z-scores to 3 decimal places, not 3 significant figures, 3 decimal places. And so now what's happened is basically we've taken the same information, but now it's got a mean of 0, and we've got this z-score here, and the area is going to be exactly the same. So all I'm going to do now is go to my calculator and fill in this. So go to menu and then number 7 to distribution, and we're going to do a normal CD. The lower boundary is going to be -9 times 10 to the 99th, an incredibly small number. Our upper boundary is going to be 0.286. You'll notice that the standard deviation is 1 and the mean is 0. So we get a probability of 0.6125609. Now, if you keep in mind that the area under a curve is always going to be equal to 1, well then obviously all we've got to do is take this first area and subtract it from 1, and that'll equal the other area. So we're going to tell them the probability of z is greater than 0.286 is going to be 1 minus 0.6212 blah blah blah, and that's going to give me a probability of 0.3874 or 0.387. All right, let's look at the next one. In problem number 2G, we've got to find the probability that x is less than 5 but greater than 2. So we've got a mean of 3. We're going to make 2 graphs here. So we've got a mean of 3, and we know that based on this, well, that the value of 5 is going to be above and the value of 2 is going to be below. So basically I got something like this, and I need to find the area in between here. And so what I'm going to do is I'm going to convert my 2 and my 5 into a z-score, and then I'm going to find the area between those z-scores. So to convert to a z-score, we're going to use our formula. It's going to be z is equal to x minus the mean over standard deviation. So for the first one, it'll be 2 minus 3 over square root of 7, and that's going to give us negative 0.37796, which we're going to round to 3 decimal places, or negative 0.378. And then the other one is going to be 5 minus 3 over square root of 7, and that's going to end up being 0.755928 or 0.756. Now keep in mind, all that's happened is we've converted these numbers to a graph that's got the same area in between these 2 points. And so all I've got to do now is find the area between 0.756 and negative 0.378. And so what I'm going to do is I'm going to find everything less than 0.756 and take away everything that's less than negative 0.378. So I'm going to write that down to let people know what I'm doing. The probability that z is less than 0.756 and greater than negative 0.378, this is how I'm going to do it. I'm going to do the probability that z is less than 0.756, and then I'm going to subtract the probability that z is less than negative 0.378. Now the thing is, I can do this first one pretty easily on my tables because it goes negative, or it goes below a positive z-score. But for this other one, I've got to convert it to a positive. So keep in mind, on the other side, it's perfectly symmetrical. So this number 0.378, the positive one, above it is the same space that's below negative 0.378. So I'm going to do 1 minus the probability of z being less than positive 0.378. So I get my calculator and I go to normal CD, It's already got a negative 9 times 10 to the 99 in there. I put in my 0.756, find out the probability for that is going to be 0.77517 or 535. And then I'm going to do minus 1 minus, and I'm going to find this other probability of 0.378. Now keep in mind, that's less than, so I'm going to have to do 1 minus that. And so when I go ahead and put that all together, I get a probability of 0.42242 or 0.422. And that's all there is for that one. All right, let's look at the next one. In problem 3b, we've got to find b given that x is a normal distribution with a mean of 12 and a variance of 4. And they tell us that the probability that x is less than b, or whatever number we're looking for, is equal to 0.9599. Now, we're going to use the graph again. We've got the mean here is 12. And what we've got to do is at least kind of get an idea where our b is located on this number line. Now, keep in mind, the probability that means to the left of it is 0.9599. That's a whole lot of it. So remember, half of it has to be below the mean. So that means it has to be over here on the right side, pretty far on the right side, as a matter of fact. Now, basically, the strategy we're going to use here is we're going to write these two things, and we're going to make each one equal to a z-score. Now, the z-score, we're going to use the formula. That's going to be x minus the mean over a standard deviation. And we're not going to be able to get the whole thing, but we're going to put in what we can put in. So it's b minus 12 all over 2. And now, to find the z-score that matches up with 0.9599, I'm going to do the inverse normal. And I'm going to put in the area of 0.9599. You'll notice it's already got a standard deviation 1 and a mean of 0. So when I do that, I find out that it's 1.7495 or 1.75, and that's 3 decimal places. And see, now all I've got to do is get b by itself by multiplying both sides by 2 and then adding 12, and I'm going to find out that b is equal to 15.5. All right, that's all there is to that one. Let's go on. In this problem, we've got that x is a normal distribution with a mean of 17 and a variance of 25. They want us to find d, where the probability if it's bigger than d is 0.0951. So that's not much. That's only like 9%. So that, keep in mind, it's above whatever my value is I'm looking at. So that means this area here is 0.0951. That's where my d is. Now, the nice thing is that I know that this whole curve is 1. So if I take 1 minus 0.0951, I'm going to get 0.9049. And that's everything to the right of d. And that's what my inverse thing is going to do in the calculator. So when I go over and set this up, I'm going to make z-score equal to z-score. And that's going to be d minus 17 over 5 is going to equal to, and what I'm going to find now is what is the value that has 0.9049 to the left of it. And you'll find that it's 1.31. And then all I've got to do is multiply both sides by 5 and then add 17. And I'm going to find out that I'm going to get a 23.5 for D. All right, let's take a look at the next one. Okay, for B, we're supposed to find G if X is less than 55 and greater than G. We know the probability between these two things is 0.5486. So here's the first one we know. We got 55. There's that bar over here. Now we don't know exactly where G is. I got a feeling it's below the mean because 54, that's half of our graph. So I feel like it's going to be over the other side somewhere. Anyway, what I need is I need to know the area that's to the left of B. If I know the area that's to the left of B, well, then I can find out what B is, well, just like we did the problem before in section 3. So what I've got to do is figure out what this area is on the left side of B. Now, I can figure out what everything to the right of 55 is. And then once I do that, if I take away 0.5486, then I'm going to have the area that I'm looking for. So let's convert this to a z-score, 55 minus 45 over square root of 50. And that's going to give me a z-score of 1.414. And so now I know that this, I'm not going to make a new graph, I'm just going to go down here. So we'll say that's 1.414. All right. Now, that's when the mean is 0. And everything to the right of it, or I'm sorry, to the left of it, is going to be this area over here. So I'm going to figure that out by doing normal CD. I'm going to put in my 1.414, and I find out that the area to the left of it is 0.9213. Now, in order to find the space, the area that's to the left of B, I'm going to take 0.9213 and I'm going to subtract 0.5486 because that's not part of what I'm looking for. So I'm going to take away 0.5486. And what I'm going to do is I'm going to use the stow function on this calculator. I'm going to stow it into x. I'm going to go back to computation mode. I'm going to do x minus 0.5486, and I'm going to find out that the area is 0.37, what was it? 0.372719. Yeah, that's right. All right, now that spot over there is the area that I'm interested in. I'm going to make a new graph here, but this is basically just getting rid of all the rest of it. Now I know that to the left of B is 0.372719. Now, with that information, I can find out what B is. So I'm going to convert these to a z-score. I'm going to go ahead and I'm going to do B minus 45 divided by square root of 50. And then I'm going to go into my calculator and I'm going to find the z-score that goes with this to the left of this value, this area here. So inverse normal. I'm going to put 0.3721719. It's already set for a z-score, and I'm going to find out that that z-score is going to be negative 0.326. So let's go ahead and fill that in. And now all I've got to do is get B by itself. I'm going to multiply both sides by square root of 50. And if you want, you can use that equation function I showed you before. We can just go ahead and set this up. X minus 45 all divided by square root of 50. And then I'm going to do equal, oops, don't do equal. Equal up here in the red, alpha equal, and then make it negative 0.326. And then I'm going to do shift calculate. And I'm going to find out the answer is 42.69 or 42.7 to 3 significant figures. And then we're done. All right, thanks for watching.